In this lesson, we're going to do some sample calculations that will help prepare you for the gravimetric analysis lab. So let's say we had a chemical reaction where we were reacting aqueous calcium chloride with a group 1 metal carbonate. In this reaction, M just stands for a group 1 metal. So our job is going to be to use stoichiometry to identify what that metal might be. So when this reacts, we are going to form solid calcium carbonate and aqueous metal chloride. So let's say we are doing this lab. What we can do is we can measure out the mass of the solid metal carbonate before we dissolve it in water, making it an aqueous solution. So we can take a scale and record the starting amount of our solid metal 2 carbonate. Again, that's before we dissolve it in water to make it an aqueous solution. Let's say its mass was 0.987 grams. When we do this reaction, we make solid calcium carbonate and aqueous metal chloride. So what we could do is isolate the solid. So we're going to do a process called vacuum filtration, and we are going to isolate out the solid, and then we can record that mass as well. And let's say the mass of our solid product was 1.336 grams. So the way that we are going to approach this problem is we are going to identify the unknown based on its molar mass. Molar mass is grams per mole. So if I want to solve for the molar mass of the metal carbonate, I already have the grams, I just need to know how many moles I have. So the important thing is to look at our balanced reaction and note that I have a 1-to-1 mole ratio of my metal carbonate to my calcium carbonate. So if I can solve for the moles of calcium carbonate, that's going to be equal to the moles of metal carbonate, and then I can take grams divided by moles and will get me to molar mass. So I'm going to start with the mass of calcium carbonate that formed, 1.336 grams of calcium carbonate. If we're starting with grams, the only thing we can do is plug in the molar mass to get to moles. Calcium is 40.08 plus carbon plus 3 times the mass of oxygen, 100.09 grams per mole. And then again, in order to solve for molar mass, I need to know the moles of the metal carbonate. So I can plug in a mole ratio. For every 1 mole of calcium carbonate, we need 1 mole of the metal carbonate. We're going to stop here and solve for moles. So I can plug this in to my calculator, multiply everything across the top. 1.336 times 1 times 1 divided by the bottom, 100.09. And that gives me the number of moles. Don't clear your calculator yet because we don't want to round until we get to the final answer. So now, if I want to solve for the molar mass of the metal carbonate, molar mass is grams divided by moles. So we have our mass, 0.987 grams. We just solved for the number of moles. And when we solve, that will give us the molar mass. So the easiest way to do that without rounding this number is you're not going to clear your calculator. Just type in 0.987 divided by the answer. That will divide it by the previous answer. And this would be what I get. .73 grams per mole. We could also take this one step further. Let's say we wanted to figure out the identity of M. Probably the easiest way to do it for a problem like this is we know that the molar mass of M2CO3 is 73.9 grams per mole. So what we can do is subtract out the mass of carbon and subtract out oxygen. So 73.9 minus 12.01 minus 48 gives me 13.89 grams per mole. But here's where we need to be careful. We subtracted out carbon, we subtracted out 3 times oxygen. Don't forget in our formula there are 2 metals. So we could take this answer and divide it by 2, and I get 6.945 grams per mole. So now if we want to identify that group 1 metal, 6.94 is very, very close to lithium. So if we wanted to identify the unknown metal carbonate, this one is most likely lithium carbonate. Let's try one more example with a different reaction. We have an unknown group 1 metal chloride, and I know that it's group 1 because chlorine is -1 and it's a 1-to-1 ratio. That means this metal has to be +1. Plus silver nitrate yields metal nitrate plus solid silver chloride. So again, aqueous just means that it can dissolve in water. So we would have a solid metal chloride and we can measure its mass before we dissolve it in water. So the starting amount of our group 1 metal chloride, let's say 0.450 grams. And then again, we are going to precipitate out a solid. So we can filter out the solid, dry it, weigh it, and get a mass of silver chloride. Let's say that mass was 0.840 grams. So we're going to do the same thing. We are going to try to identify the unknown metal based on the molar mass. So let's start with what we know. We know how much silver chloride we made. If we're starting with grams, the only thing we can do is plug in molar mass to get to moles. So using my periodic table, silver has a molar mass of 107.87 grams per mole. Chlorine, 35.45, 143.32. 143.32 grams of silver chloride per every mole of silver chloride. Next, we want to solve for the molar mass of the metal chloride. I already have grams, I need moles. So next we're going to plug in a mole ratio. In this case, it's a 1-to-1 mole ratio. All right, let's plug in what we have and solve. And again, we don't want to round this answer. Ideally, we only want to round when we get to the very end. All right, last step. Again, in order to calculate a molar mass, we are going to take the grams and divide it by the moles. And again, this is of our metal chloride MCl. So my mass in grams, 0.450 grams divided by moles. Again, best way to put this in your calculator, don't clear this, just type in 0.45 divided by second negative to get that answer. And I get 76.778. We want to round to the appropriate number of significant figures, which would be 1, 2, 3. 1, 2, 3. So 76.8 grams per mole would be my molar mass. Let's say we wanted to solve for the identity of M. So the molar mass of MCl minus the molar mass of chlorine And again, we know that it has to be a group 1 metal. Chlorine is in group 7. It is a halogen. Its charge is -1. Ionic compounds are neutral, so that means that the metal has to be +1, meaning it must be group 1. So we're looking for a mass of about 41. Sodium's way too low at 23. Rubidium's way too high at 85. Potassium with a mass of 39.1 would be our closest. So M, that unknown metal, is most likely potassium.